So that should start the recording. And I should play this. This should work. All right. So again, this is nothing numerical, no calculations for today. So just kind of, sit back, put your feet up a little bit. And everything that we see on the slides is going to be testable. I'll try my best to let you know like exactly what you need to get ready for the exam so that there's no surprises. And where chapter 1 starts off with is this definition of statistics, because we're in a statistics course. And they tell us statistics is the science of conducting studies to collect and organize and analyze and draw conclusions from data. And you read that, and what's the first thing that you say? You go, what? Okay. It doesn't make a whole lot of sense. It's kind of a mouthful. So the idea is, consider this scenario. You have 5 friends that you invited over into your house, and they're in your living room. And you go and you record everybody's body weight. So you write down their weight, and maybe you calculate the average. You find the maximum weight, who weighs the most, who weighs the least. You write that down, and then you say to your friends, guess what? We're going to go on a 10-mile jog, and I'm going to try to guess your weight at the end, like how much weight you're going to lose by doing this 10-mile jog. And your friends are like, we're going to do what? Now, what's important is there's 2 things going on. The first is the information that anybody can validate. Like anybody can walk in and they can see that the numbers match exactly what somebody weighed on the scale. Anybody we ask in that room calculate the average, they're going to get exactly the same average. They're going to find exactly the same maximum weight, the same minimum. What's the part, though, that we can't validate? What's the piece that kind of has an opinion in it?
How much everybody will lose?
Exactly correct. We're guessing at it. So there's the 2 halves to statistics are things that we're saying that are our opinion and what's completely verifiable that anybody can walk through the door and validate. So to help us understand a definition, we get 2 pieces of statistics, like 2 main branches. And descriptive statistics is the collection, it's the organization and the summary and the presentation of data. The key is anybody can come in and validate it. It doesn't have our opinion in it. So when we're collecting weights, even though we're just writing down how much somebody weighed, it's actually still a statistic. It's just a descriptive statistic. When we're summarizing it, all we're doing is maybe calculating average, adding up all the numbers and dividing by the total. That's a statistic. So it doesn't have to be complex. It could still be a simple descriptive statistic. Maybe even you beam it up against the wall. You do a PowerPoint of everybody's weights, and that would be a descriptive statistic. Once you want to put your opinion in, where do you have to go? You have to go to the right side on inferential statistics. So that's where you're making the generalizations. That's where you're making the predictions. You're saying stuff that might not be true, that nobody can vouch for. That's the part where you're guessing how much somebody's going to weigh when they finish a jog. So at the end of the day, here's exactly what you need to know. The descriptive stuff, it's information that's already been validated. The inferential is, it can't yet be validated because it's somebody's opinion. You might have somebody with like 3 PhDs. They're making inferential statistics. Their PhDs don't matter because it's still their opinion. Everybody feel pretty good about the difference between descriptive and inferential. Okay, let's do a couple examples just to make sure we're feeling really good about this. So do one a descriptive. If we were in a classroom and we said 25 students in the class, that would be a descriptive statistic. Anybody can come on in, they can count up the number of people in there, they're going to keep getting 25 each time. Maybe we take the test. We get 15 students, they got A's on the first exam. An A is 90 and above, so no matter who we give the exams to, so we tell them sort them out, please get all the A's in one stack, everybody else in another. We're always going to end up with 15 in one stack each time. Everybody good so far? Okay, so let's hop over to inferential. Now we go and we say we have 25 students in the class, so next summer we're also going to have 25 students. Do we know what's going to happen next summer? No, sure don't. Inferential statistic. How about we look at those A's on the exam, and 15 of them, well, all 15 of them were women. So now we turn around and we say, women are better at math than men are. Is that true based on the information we're reading off of? No, that gets us into the gray zone. We really don't know if women are any better at math than men are, and we definitely can't say that based on the information we have. So it would be an inferential statistic. Okay, so next thing we're going to start to talk about is populations and samples. Now, population in statistics, we refer to all subjects that are being studied. And that might be like all the people we have in this class right here taking statistics, or it could be everybody at Bergen Community College. So it could be people, or it could even be all the dogs at the dog rescue shelter in town, or even all the fish in the Hudson River. So somebody's going to have to tell you what your population is. Like when they do a study or in a homework exercise, they have to let you know what it is they're looking at, or otherwise we don't know what to do. Now, then we get this thing called samples. And a sample is a subset of the population. But what's the biggest thing that you guys can think of happening in the news right now? Like the biggest thing that has to do with opinion, public opinion. Like just throw out the first thing you can think of.
The election?
Perfect. All right. Excellent. Like the election. If you're in charge of a campaign and you need to know your candidate, what's public opinion, you would love to interview every single American. And do you want this person to be president? Do you want to? But will we have time to do that?
No.
No, we can't make it happen. So we have to take a sample out of the population, and then you got to generalize about the population based on what we see happening in the sample. Do you get into sampling error? Yep, you do. The sample won't be a perfect representation of the population, but at least we can get something done. Now, here's why I'm mentioning this. I will not ask you anything about a sample and a population directly on the test. Like I'm not going to say define a sample. I won't say define a population. Here's exactly where you're going to need it. When we get into the later chapters, chapter 3 and 6 and 7, we skip 4 and 5. But those later chapters, what's going to happen is where your information comes from, like if it's a sample or a population, it gets to be really important. Which do you think would be more valid? Data from a sample or data from a population? And I think that was, I can't see the name, but I saw somebody raising their hand. Just go ahead and shout right out.
Would it be data from a population?
You mean as being more reliable?
I think so.
You're exactly correct. We would love to have data from a population because it's much more reliable. Remember, when we have a sample, it means we generalized a lot. So whatever we say is a little bit risky. So here's why I mention it. Whether or not your data comes from a sample or a population, it just affects the error that we're going to have to put into a calculation. And that's down the road in chapter 3, we'll get that. So that's why we're mentioning it now. Anybody have any questions so far? Okay, so we'll keep going on then. When you're talking about populations and you're talking about samples and stuff like that, in statistics, we get different kinds of data. We get qualitative data and quantitative data. These will definitely be on the test. This is important. So of the two, like how do you know the difference? What is the difference? The qualitative data is any information that's not numerical. Even though we're doing statistics, it doesn't mean that every single thing has to be a number. You can have stuff that's alphabetic. And a really cool way to remember this, inside of the word qualitative, think of lit, like literature. And I'll think of going into Barnes and Noble. And I get like a romance book maybe from the shelf. I open the romance book. Does the romance book have all kinds of math equations in it and stuff like that? No, of course not. It's just a story about people falling in love or something. So I know I'm going to think of literature that'll help me remember it's non-numerical. Now, what kind of things would be qualitative? A good one might be hair color. You can go around and record like who has pink hair, who has gray hair, who has purple hair. And It might seem kind of simple information, but who would pay up a lot to know prevailing hair color trends?
Cosmetologist.
Yeah, you bet. Like cosmetologist, L'Oreal, or I'm trying to think of other companies like that. Revlon, would they pay millions of dollars? Do they pay millions of dollars to find that stuff out?
Yeah.
Oh yeah, you better believe it, right? So to them, that's really, really valuable information. Now, what else can you guys think of that might be qualitative? Just keep it clean. That's the only thing I ask. Don't go triple X on me.
Would like opinions be qualitative?
Yeah, sure. You could say, I want to know, a really cool way to do it. I like dogs, so you'll probably hear me do a dog example from time to time. Like, I want your opinion. What's your favorite breed of dog? And you say collie or golden retriever. That would be qualitative. Maybe what kind of car people drive. You could record information, and that would be really important for car dealerships to have. Now, that is not my car, by the way. I just threw that in there because it looks cool. Okay. Everybody feel okay with qualitative data? Any questions on anything? Okay, I'm just going to take a second to try to make sure that we don't seem to have any questions in the chat room. We're good there. Okay, so what we'll do is we'll get into quantitative stuff then. Now, quantitative, what's quantitative? Well, if qualitative was non-numerical, what do you think quantitative is going to be?
Numerical.
Numerical.
Exactly correct. Well done. So it's going to be numerical information, and we have two distinct kinds that we have to know about. So I will ask you for these on the test. First kind is going to be called discrete. This is the easy stuff. And then continuous is a little bit more complex. So we'll start in with the discrete. And discrete is basically, think of it as anything that you can count up. Anything that's a whole number. That is going to bring in the discrete category. And a few examples of that so we can get to know, because on the exam, I'm going to ask you things like number of golf balls in a bag, or the number of spare tires you put on your car, discrete or continuous. Tell me which one. So if I'm going golfing, I'm going to bring a whole bunch of golf balls with me. Can I tee off with half a golf ball? Would that make any sense? No, like I can't take a golf ball and slice it in half and put it on the golf tee. We don't see anybody do that unless they had, like, you know, a case of wine or something. So that would be a good example of discrete. If we have, anybody have a birthday this month? Okay, just wondered. How many birthday cards you get would be discrete. Can we open the mailbox? If we get birthday cards, can we count how many we got? We sure can. Can you get a fourth of a birthday card? Like, do you have a friend that would take a birthday card? Yeah, do I have a, like, they would take your birthday card and they rip it in half and they send you half a birthday card. Do people do that? No, people don't do that. Of course not. Well, maybe they do, but they're not going to be your friend for very long if they do that to you. So that would be discrete. And one thing we haven't done in a long time, fly on an airplane probably. So if you get on an airplane and you walk down the aisle, can you count the number of seats on a plane?
Yes.
Yeah, sure. Now, can you go in the airplane and find 1/5 of a seat sitting in there? Do they do that to you? No, of course not. So that would be discrete. Anybody else have any questions on anything about discrete so far? Okay. Continuous data. So continuous data is fractions and it's decimals, and that's information that you usually cannot count up. So one thing that we love to happen probably, if you're taking classes in the spring semester, you have an exam coming up. The night before the exam, it's freezing cold. What do you hope happens in the weather forecast so you don't have to take that test?
It snows.
Yeah, we hope for snow, right? Or if you were here in the spring, how many of you guys were here with us in the spring semester? If
I
you
was.
were, One thing we had was not snow, but we had a lot of fire alarms. I think we had about 5 of them in the spring semester.
Mm-hmm.
So, yeah, somebody knows what I'm talking about.
Yeah.
Yep. If we have the snowfall coming down, can we look out the window with our eyes and can we count the snowfall?
No.
No, of course not. Like, we can't count the snowflakes, but can you get a fraction of snow? Like, can you get 3.5 feet of snow or 3.5 inches of snow?
Yes.
Yeah, sure. And if you're in New Jersey, you cancel school for like 3/4 of an inch of snow. We do that here. We cancel school when it didn't even snow. The night before, we'll do it.
Mm-hmm. Mm-hmm.
If you have friends from Buffalo or something like that, and you tell them what we do here, like canceling school and 1/2 inch of snow, boy, will they laugh at you. Okay, another example. How much water is in a pool, maybe? If you're sitting there, you're filling up a pool. Can you count the droplets of water in the pool? Like, can you walk up to it and start counting how much water is in there?
No.
No, it won't work. However, I can measure it with a fraction or decimal. Like, I could say I have 30.2 liters or 3,000.8 liters, and I can get a decimal or a fraction out of that. And that would make us continuous continuous data. Any questions on the difference between continuous and discrete?
I just had a quick question
Sure.
or a comment. I thought that I kind of understood this concept reading it, and then I did question 9 on like what the quiz in the book
Is that the DVD
asks
one?
is something. DVD. Oh yeah,
I think I know what you're talking
that's
about.
one
That
of
one's a
them.
mistake. It's supposed to be discrete.
Oh really?
Yeah. You noticed
Well,
well.
just in general, I had trouble answering them. Like I thought that I had a handle on it until I saw concrete questions, and then it was a little more confusing.
Are there
If
any
maybe we can go through those at some.
Are there any that you
Um,
got in front of you right now?
Like, let's see, yeah. I
And
have
I'm
them
going to
here.
open up the book on my side too.
Okay. The weights of cats in a pet shelter.
Great example. So if we're thinking about cats and we're looking at a cat, can you look at the cat and let's see if it shows your name here next to your screen. For some reason it doesn't. What's your first name?
Ashley?
All right, great. Ashley. So if we're looking at the cat, can you look at the cat and count the weight of it?
No.
Like just with your eyes? No. Now, when you put it on the scale, can you get the cat weigh maybe 12.2 pounds or 12.8 pounds? Like, can you get a fraction out of it?
Yes.
That tells you it's going to be continuous.
Okay. Okay.
Any others?
The lifetime in hours of 12 flashlight batteries.
Okay. So if you're thinking about how long the flashlight's going to last for, can it last for 12 hours, like 12.1 minutes?
Yes.
12.2 minutes?
Yes.
Okay. Now, can you count the hours as you're holding the flashlight and shining it around? It's say like, not very well, not like counting gumballs or something like that. So your immediate factor is going to be, I can get a decimal on it, so it's going to make it continuous.
Okay. So the number of DVDs rented each day by a video store, you said?
Discrete.
The answer was,
That's
just, yeah.
You're
Okay.
exactly correct. That's supposed to be discrete, and they wrote down continuous for it.
Okay.
Are these questions from the homework?
Yeah, they're questions from the homework, straight out of the back of the back of the section.
Okay. Where do I find the homework again?
That's going to be when you open your PDF for chapter 1, right at the end of the chapter, there's going to be a set of questions, and your homework questions have a big red box around them, so you can find them right away.
Okay. Thank you.
You're very welcome. Your solutions manual is also in the same spot for the folder marked week 1 of the course.
But that's not actually homework we have to like turn in.
You're exactly right.
Right. Okay.
Mhm.
Okay. Thank you.
You're welcome. And I'll probably have 2 or 3 questions on the test where I'm going to throw you guys out scenarios. I'm going to say something like, it's a good example that I haven't used. Well, you guys give me an example of discrete. I'm tired of hearing me speak. What might be something discrete?
A certain
Number
brand
of
of car.
masks.
Whoa. Okay, try again. I think everybody spoke at the same time.
Go ahead.
I said a certain like brand of car in like a parking lot.
I love that. That's awesome. Because can you count the cars in a parking lot?
Yeah.
Sure. Now, can you have an eighth of a car sitting in a parking space?
No.
What if we're newer? No, just kidding. So I can definitely not get a fraction on it. It's only going to be a countable number. So it's going to be discrete. And on the test, I might say, like, of all the following, which is discrete? And it would be cars in a parking lot, volume of water, temperature, miles an hour. And then you're going to pick out the one that you can count and comes in whole numbers. Any other questions? All right, let's bring this back into play mode here. Okay, so inside our discrete data, inside our continuous data, we have these things called measurement skills. And measurement skills have to do with how sophisticated your data can get. Sometimes when we're doing statistics, our information is very, very superficial. Like all you did was record somebody's hair color and you can't get an average on it. You can't find out which hair color is the maximum hair color because it just doesn't make any sense. And sometimes your information you can analyze really well right out of the box. So you have 4 categories that tell us how sophisticated the data is going to be. When we're on the left with nominal, nominal is going to be like the simplest kind. And you don't have to write down the graphics coming up now. We're just introducing what this section is about. It's the simplest kind. And as we go further to the right, they're going to get more and more and more complex. So by the time we get to the right, you're getting information that's going to be in the form of continuous data most commonly, and you can analyze it without having to do anything to prepare it or anything special. And most of the stuff we're going to do in the class will be in ratio level. And you're going to need to know the definitions of each measurement scale. I'm just going to ask everybody to pause if you're not speaking because we're getting some kind of a vibration in here. Now, when I say the definitions, like we're talking max 2 sentences that you would need to identify. So these are very, very basic definitions. And we'll take a minute to go through them one by one here. So if you have something like nominal, you need to know that nominal information is the simplest kind of data. It's comparable and it's categorizable. The catch is that there's no ranking possible. Like you don't have any way of taking one data value and saying that it's any better than another data value. And you need to know that sentence, like that's going to be definitely asked. Example of this would be something like somebody's phone number. If you get somebody's phone number, like you get a new phone, you get a phone number, do you care? Like, is one phone number cooler than another phone number or better, or you just want to get the numbers in the right order? Most of the time, you just want to get the numbers in the right order. If you think about nationality, we can easily say we're in a room, we have 4 German people, we have 2 Australians, we have 3 Mongolians, 4 French people, and we can compare the categories, but can you say the Australians are better than the Germans?
No.
No, of course not. Can you say that people from Mongolia are better than people from Brazil?
No.
No, it won't work. So we don't have any way of saying that there's a ranking we can put in on the data set. And if we want to get a ranking, we can do that as long as we bump to ordinal. So ordinal is going to be our next category here. And when we think about ordinal data, it's information that we can rank it. But the catch is that there's no precise differences available in any of the data values. So what would this stuff look like? What would be like a rankable data value, but you can't precisely define it? Who do you think is the highest paid actor or actress of all time right now?
I know about right now. I don't know about all time.
Okay, yeah, let's all right, fair point. Let's say right now, who's the highest paid actor, actress?
I think Dwayne Johnson.
You are exactly correct. Yeah. It used to be Tom Cruise. And I think until like 3 years ago, not Tom Cruise anymore. Thank goodness. Anyway, Dwayne Johnson, The Rock. Anybody know where he's from, by the way? He's actually from pretty close to here. He's from Allentown, Pennsylvania. So The Rock comes in, and well, The Rock gets a movie contract. The Rock will not sign up for a movie unless anyone know how much money he gets paid. This will blow your back of your mind right off. Take a big guess on how much he gets for each movie contract.
20 mil.
You're really close, but it's higher. It's about $24 million. I see some people. It's true. He will not act in a movie unless you give him $24 million. And he was, during interviews, he's been asked, like, how do you get as big as you are? Because we're about to do something with body weight. This is where this is going. And the first question, like, how did you get this muscular? And his alarm clock goes off at 3 o'clock in the morning. By 4 a.m., he's in the gym already. And like that's part of his discipline. I guess that's how he's making his $20 million. Anyway, when he comes in the room, he's standing, well, if he came in the room and he's standing next to me, think about body build. How can you measure somebody's body build? Like, how would you classify it? Like, anybody ever filled out a job? Say again?
Body mass index.
Oh, even easier, even easier. Like if you're on an application for firefighter academy or police academy, sometimes they'll ask you what your build is, and you put in these 3 letters: small, medium, or large. Oh, sorry about that. That's the next example. Small, medium, or large. So if The Rock is standing next to me, which one is The Rock? Small, large, or medium?
Large.
Yeah, he's large. I'm small. Is it obvious that he's larger than I am? You can say yes, it's okay.
Yeah.
I'm small compared to him. He's huge, right? Now, so here's the tough part. Exactly how much stronger is The Rock than me? Can you figure it out?
Not by looking at it.
Right, yeah, you would kind of be like, I don't know. Like, I know he's stronger than I am, but I don't really know by how much. So there's no there's no real way to rank it. Here's another example. What do you like to get when you can go to happy hour, if they ever let you do that again? What's something that you can order when you go to happy hour?
Drinks.
Yeah, what do we like to get with the drinks?
Wings. Mozzarella sticks.
I think Isabel saw something ahead.
Yeah.
So Isabel is sitting down there and she's getting her hot wings. What's the server going to say? How would you like your hot wings? Would you like mild, hot, or inferno? And Isabel says, I want the inferno wings. And somebody's sitting next to her with mild wings. Are Isabella's wings much hotter than the person that has mild wings? Absolutely. Yeah, for sure. No question about it. Can you tell, though, exactly how much hotter they are?
No.
No, all of a sudden you're at a loss. You just know they're hotter, but you don't know by how much. So I don't really have any way of getting a precise difference off of that. Some people will say, like, well, what if you do a scale of 0 to 10? Will that work? Only so far. Like, Isabella, do you like spicy food?
Yeah, I do.
Okay, so is there anybody that does not like spicy food? If Isabella loves spicy food and somebody is sitting next to her that hates it, are their scales of 1 to 10 going to be different if you're asking them to rate their, yeah. Like we could say, Isabella, scale 0 to 10, 10 is the most spicy, 1 is like weak. Her scale is going to be really different than somebody else's. And it won't be anything we can really standardize. So that's how it gets to be ordinal level. And there's our body build example coming in. Anybody have any questions about ordinal and nominal yet?
I have a question. So
I have an answer.
what might be infernal to me can be mild to you.
Absolutely. That's
So-
what makes this so much fun.
And what category does that falls in? Like,
It's going to be ordinal because there's no precise way to measure and say how much hotter than another. You just don't have the data. Like some people will say like, oh, what if we measured the cayenne and the recipe, like how many teaspoons? It's like, well, we don't have that available. We just have the mild and the hot and the infernal.
okay.
Any other questions anybody has? Okay, so what I'm going to do is I'm going to take a pause for a small minute. There's a couple more categories we have left, but I need to make sure I get in here and track the attendance information. So what I'm going to do is I'm going to stop sharing this screen, and I'm going to roll over to the chat window. And there's two things I can do for the attendance. Usually easiest way, if you have your picture on, I can just write your name off your picture because I know you're here. If you don't want to turn your camera on or you can't, just write in here on the participants, sorry, not in the participants, in the chat room, and then I'll know you're here. And I can just take a few minutes, I'll record the names. I'm gonna get something to write with. So I don't get paid if I don't do the attendance, so you gotta do that. And in about 10 days, they're gonna send me an email. They're gonna ask if there's anybody that has never attended the course. And if you haven't, you can get really jammed up with financial aid because they wonder what you're doing with the student loan. And I think what I'll do is I'll take some still pictures of this. It'll be even better and faster. Oh, I should probably mention this. I see a lot of people that are entering names like Blade Runner or Eddie or something like that. I don't know who that is. So make sure you're using the name that you registered under. Like I see, it says Carson to everybody, but by the first name, I don't know who Carson is. Okay, I see Deanna wrote everything. Thank you, Deanna. I see your whole entire name. That helps me a lot. Okay, great. 1, 2, 3, 4. And I'm going to do this to get. Oh, good. There's more coming in. Great. What's happening is I'm looking at people's pictures and I notice that sometimes the picture doesn't have a last name in it. So like I'll see, for example, Moshe, or I'll see Isabella, or I'll see Jaiwu, but it won't give me the last name. So I can't identify the person on the attendance list. Okay. Moshe I know well, so. Moshe, how do I say thank you in Hebrew?
Toda.
How's that again?
Toda.
Ada?
Toda. T-O-D-A.
Oh, Toda. All right, great. I'm going to write
Toda.
that down.
Yes.
I'll learn something. All right, Toda, yes. Okay, before we start to roll back, questions about anything that anybody might have? Or if you even dialed in a few minutes late and there's something you wanted to know that you're not sure if we talked about it already. Okay, so I'm going to flip back over to the keynote, and what we'll do is we'll probably do a few more minutes of the slides, and then I'll stop for a few minutes in case anybody has questions. That way we'll have plenty of time for QA and stuff like that. Then we'll summarize everything we talked about today too.
Professor, so we don't, I'm sorry, we don't hand in our homework, like we don't send it to you like after we're done?
No, not at all. You won't have to. The reason why is there's already a complete solutions manual up on the internet with step-by-step solutions. And what's eventually going to happen is when we get into the later chapters of like chapter 6 and 7, you guys are going to get assigned like as many as 40 homework questions in one night. Do you have to do all of those? No. You might say like, okay, I got this down. I practiced it 2 or 3 times, and now I want to go to something that's of much more importance to me. Like I have to go back and study some stuff from another chapter. That way, you're not compelled to spend 4 hours on the questions and then submitting them.
Okay, so what is it that we do have to hand in? I overheard you or someone saying that we have to hand something in.
Okay,
That's
so
not homework, but it's something
really
else.
important question. What do we hand in? The only thing you have to worry about is the 4 tests.
Okay.
And they go in on email, so you don't have to worry about finding a link on the website on Moodle or anything like that. It's trying to keep it as simple as I can.
Okay, so the only things we're handing in are the exams.
Exactly correct. Yeah, the exams.
Okay. All right. Thank you.
You're very welcome. Anybody else have questions? All right. I'm going to make sure the chat room is yeah, we look good. Okay, I don't see any questions coming in there. I'm going to flip back to the keynote. Okay, I think you all should be able to see my screen. I have to just move something out of the way here. Not better, great. All right, so we talked about ordinal, and the next 2 we're going to speak about will be interval and ratio level data. So they have something in common. In both cases, you can finally get precise differences that will exist. And the difference, we figured that there would have to be a difference. The difference is something called absolute zero. How many of you guys have done your chemistry course and you had to work with absolute zero? Okay, see some people nodding and some people making kind of like funny faces when they say yeah. The good news, you don't have to calculate absolute zero. Don't worry about that. For us in statistics, absolute zero just means what? Anybody know what absolute zero means? It means if you're measuring something and it has an absolute zero, you can't go negative. If there is no absolute zero, it means that you're not out of what you're measuring. And I will not ask you what absolute zero is on the test. Don't worry about that. It's just a part of the part of what helps us understand interval and ratio level data. So what's the big deal with absolute zero? A good way to get our head around it, if we think of an example of interval data, would be something like temperature. If we have 2 different ovens, one is at 200 degrees, another is at 400 degrees, can we finally say that there's a difference? 400 and 200 degrees is a precise difference, it's 200. Is that fair now? We can do that, totally legal. Now, if you're thinking about, okay, interval data, I have to meet 2 definitions. I have to have precise differences, I just met that, and I can't have absolute zero. If you are at 0 degrees, are you out of temperature? Can we go negative with temperature?
You can go negative in
Yes.
temperatures, but not in ovens.
Yeah, sure, you can, right? So we can go outside and we can have it 30 below or we can have it 50 below. So what happens is there's no absolute zero. And what that does is it puts us in this really funny spot. So here's what I'm going to ask you guys. Something to think about for a minute. We agree that 400, the number 400 is twice as much as 200, right? Fair to say, yeah? Can you say that the temperature that's 400 degrees is twice as hot as the temperature that's 200 degrees? What do you think? Can we get away with it?
Say that again.
Sure. Do you think we can say that temperature at 400 degrees is twice as hot as the temperature that's 200 degrees? It's really going to make you think for a second.
Unless we put our hands in or something and feel it, I wouldn't know. No, I don't know.
Okay, it's actually tricky if you stop to think about it, because we know 400 is 200 times 2, but with temperature, we actually can't do it. And the reason why is we don't know theoretically where temperature starts from. Like, what's the coldest temperature you could think of?
0 degrees.
Can you go below 0 though?
Yes.
Sure, like you
Yeah.
can you get colder than 20 below 0, like -20? You can go into like -100, like if we go up to Venus where it's frozen, -10,000 degrees. So technically we don't know how much to take and multiply by 2 because we don't know where temperature started from. So because of that, we can't say 400 degrees is twice as hot as 200. And here's how you can really see it happening. Who loves to cook? Do I have anybody that likes to cook? Okay, that was, somebody raised their hand first, and let's see if I can. I'm trying to see, I guess I have to do something to be able to see the names that are coming up on the screen, but I have a few people that raised their hands, so here we go. If we're gonna cook brownies, and it says on the box of brownies that we are gonna cook for, I have to bring this back because I switched the screen for a sec. It says cook 400 degrees for 20 minutes. And we're saying we're going to make the brownies, but we don't have 20 minutes. We have 10 minutes. What do we try to do instead? Instead of 400 degrees, what do we, yeah, exactly. We try to up it to 800 degrees for 10 minutes. And my chefs in the class, what happens to the brownies?
They get burned.
Yeah, what happened to your whole kitchen?
Smoke.
I see people laughing like it's probably happened to a few of us. Okay, is it gonna work? Can you switch around the temperatures and the times? Or is that just, it's not gonna happen, right? So that's the reason why is because it's interval level data and you can't make ratios out of it. Now, all you need to know is that precise differences exist, no absolute zero. That'll capture us pretty well for interval level data. We're going to spend most of the time in the class with ratio level data, so let's talk about that stuff a little bit. If we do ratio level data, we have an absolute zero, finally. And a nice example might be something like distance. If you're driving to work and you drove 1 mile, and somebody else drove to work, they drove 10 miles, can we get a precise difference between the 1 mile and the 10 miles? Would that work for us? It sure would, yeah, absolutely. Now, if you're at 0 miles, can you go negative? Like, can you get negative distance? Anybody know who proved you can't do negative distance?
Ferris Bueller.
That's exactly correct. How did Ferris Bueller prove it?
You can't go backwards and erase the mileage.
That's right. What did Ferris Bueller try to do?
Go backwards and erase the mileage.
Lauren, you're exactly correct. He had a, what kind of car was that, in case nobody knows?
It's a Ferrari, right?
Yeah, classic Ferrari. Ferris Bueller is in this, Matthew Broderick was in this movie, Ferris Bueller's Day Off. They had this classic Ferrari that Ferris Bueller's friend owned. His friend was Cameron, and they took it out for the day, and somebody stole their car, and they put like 400 miles on it in one day. So they tried to put the car on stilts, run the engine in reverse, roll off all the miles. Did that work? No, it did not work. So anyway, distance does not have an absolute zero. And if one person drove 10 miles to get to work, one person drove 1 mile, what's the ratio? The person that drove further drove how many times further? You just say 10 times as far. And don't worry, I'm not going to ask you for ratios on the test. I just need you to know ratio level data is precise differences, and we have the absolute zero. That'll be enough to get you through what you need to know. One more example, just so we kind of feel this stuff out a little bit, would be bench pressing. Who likes to go to the gym? Well, maybe not anymore because they're all closed. But anyway, if we are bench pressing, and we have somebody that's bench pressing 100 pounds, somebody that's bench pressing 300, can we get a precise difference between the two of those? I'm really good at waiting, guys. I don't have anything until dinner.
Yeah, it's 3 times as heavy.
Perfect, exactly correct. Now, can you bench press a negative amount? Like, have you ever gone to the gym and somebody said, what do you want to bench press? And you said, I want negative 50 pounds. Does that make any sense? No, it sure doesn't. So we know we're ratio level data because we get precise differences and we have absolute zero. Okay, I just want to stop for a little bit and summarize things because we've been here for about an hour. And I think when you're on the online system, it's a bit more of a grind than when you're in person. So I like to go a little bit slower if I can. What questions do you all have so far? Okay, I need to make sure that I can see the chat window. So I'm going to switch my screen a little bit.
I have a question.
Sure.
So when the test about to come up, are you gonna do like a review, or are you just gonna give us like, are you gonna do it like the day before, like a review?
That's a really good question. And the answer is, I will do kind of a worksheet, but it's just meant for pacing. The best way to get ready for the exam is to understand, and I don't want to say memorize, but to know really well all the highlights in the book and to work the homework questions. The worksheet usually will, I'll get emails from people and they'll say, I thought I was going to do really better on the exam, but the practice test didn't help me. And they're sitting there trying to figure out how the person next to them or the 10 people next to them got hundreds. And it's because the 10 people went through went through all the homework questions, and that one person did nothing but the review sheet. The questions that you guys get on your exam are going to be different than what's on the review sheet. So the best way to prep for it is when you guys see the highlights in the book. Let me see if I can actually get the book on screen for just a second so we can mention a little bit more of the effective ways to prep for the test. Before I do that, just to recap a little bit, we talked about inferential statistics, descriptive statistics. What's our, like if you're going to think of the difference between those two, remember one is valid information, another is somebody's opinion. We talked about populations and samples. We talked about qualitative data, quantitative data. We know which is which. We know that in quantitative data, we have discrete data, we have continuous data. And we talked about our different measurement scales, our ordinal, our nominal, our ratio, and our interval. What I'm going to do now is get the textbook on my screen so we can answer the questions about how to get ready for the exam and the homework stuff. Give me a second to switch screens around. Okay, this looks good. I'm just opening the files I need to. Okay, I should be able to share this. Perfect. My screen is going to look a little bit different than yours because I have an instructor's view and I don't know where the student view switch is. What I'm going to do is open up the copy for chapter 1 here. This is what I want you to see. And we're almost done. We just have a few minutes left. We're mainly going to be doing some wrap-up stuff now. Can everyone see my screen?
Yes.
Okay, great. So at the end of the chapter here, well, as we go through the chapter, everybody see these red boxes?
Yeah.
Okay,
Yes.
so when you see the red boxes, those are the things you have to know cold for the test. You're probably going to have on the first exam like 20 multiple choice questions, and they're going to be all geared into what you see highlighted. The worst way to get ready for the exam, and people try to do it each time, I'll just leave my PDF open, and then whatever the question is, I'll go back and I'll look it up because I have 24 hours to take the test, and I'll do the questions that way. Is that going to help you get the questions right? No.
No.
No, you might get like a 40 on the test if you do that. I know it sounds really easy, like all the things I need to know are circled in a red box, so I'll just match that up to the multiple choice. What makes it a little bit more difficult is there's 3 chapters of it, so that's a lot of stuff to have to go through. If you know where everything is because you studied it well in your notebook, it's very, very, very fast on the other hand to refer to it. And what I'm going to do is I'm going to get one of these as an example. On the screen, if you see discrete and continuous, what I recommend doing is cover that up when you're studying and see if you can explain that to an imaginary person. And you can talk for 2 minutes on what discrete is about, what continuous is about, and how to recognize it. If you know, for example, discrete is only whole numbers and countable, see if you can explain why it is out loud. And if you can do that, it means you're ready for the test. If you can't, like, okay, I know it's countable, but that's the only thing I can remember. I can't really explain what it is behind that. That means you're not going to be ready. You're going to miss a lot of questions. In the back of this section here, I'm waiting for it to catch up with me. If I go too fast, it's not going to paint well on the screen. Okay, everybody see these boxes here?
Yeah.
Okay, those are going to be your homework questions. And I think I have got another one on the other page here, 2 more. The one that says the systematic number 12, the information for that is contained inside of the textbook. It's about 4 paragraphs that you're going to read. We're not going to go through it on the lecture because we're out of time, and it's just 4 little paragraphs. I usually let's see, persistent. I usually don't even ask those on the test. They're just something there that'll tell you a little bit more about how sampling techniques work. In fact, I don't ask those on the test. Okay. And let's see if there's anything else that we want to call out or mention here. All right. So
I have a question.
Yeah, ask for whatever questions you guys have. I'm going to turn that off.
Sorry, just you said that you don't ask those kind of questions on the test. So the questions like the
sampling technique.
DVD store or whatever.
Oh, those you'll get.
Yeah,
the questions, and specifically, Ashley, the ones about the sampling techniques, I usually don't ask on the test.
Oh, okay. Sampling techniques.
The reason why is because it's a little bit out of date in the textbook. There's only one that's helpful, and that's the one that's in the readable information. It's basically, they do a section on random sampling, and the only thing you needed to know about random sampling was it means if you're going to make a random sample, simplistic explanation of it means everybody has an equally likely chance of being picked. That's all.
Are you talking about the classification?
Yeah.
Of samples, like random, systematic?
Yeah, and there's a big arrow on
stuff.
it. It'll say just know that, and that'll match what I was talking about.
Okay.
So what I'm going to do is, I know we're done at 4:30, but I'll stay here for like 10 minutes in case anybody else has questions. What we'll do on next time we come in Tuesday, we're going to be into chapter 2. And chapter 2 is where we start the quantitative part of the course. So you're going to want to have a calculator pretty close to you. The calculations in chapter 2, they're not going to be very complex, but there's going to be a lot of them. And after a while, you just get tired of thinking, and you're going to want something to just punch in like 10 plus 10 and get the answer without your brain going dead on you anymore. So I'm going to pause for a while. Any questions that you guys have, I'm happy to answer. About probably 3 hours from now, I will be able to send you a link with a recording to this whole thing on YouTube. So in case you want to go back and study again, review any information. It'll be there in a file for you under week 1 of the course. What questions do you guys have?
So for chapter 2,
Sure.
we're gonna need the calculator, right? And is it gonna be straight from the textbook or like PowerPoint?
That's a really good question. Most everything is going to be from PowerPoint. They're my own slides, though. They're not from the publisher at all. In particular, for chapter 2, and I'm glad you asked, because chapter 2 is frequency distributions. That's one where we work an example straight out of the book, and I usually don't do that, but frequency distributions, they're kind of detailed, and I want you to be able to follow along exactly with the textbook if you
Yeah,
need.
that's exactly what I wanted to do.
Yeah.
Okay, thank you.
It's one of those things where frequency distribution is a chart that you're going to be making that summarizes a data set, and it's got like 8 columns to it and 10 rows. And you really want to have a couple reference places to look very quickly if you get lost. That's why we pull the example straight out of the book. Otherwise, I try not to do that because I find it puts people to sleep. Like if I do the same examples that you're reading of the book, people tend to tune out a little bit. I think I saw another hand raised there. It says, I'm using a Casio Plus, not Texas Instruments calculator. Will I have difficult time following a course? Let me see if I can find Aram here in the window. There's some calculators that are really awful for the course, and I can tell you exactly which ones they are. I'm gonna see if I can find Aram's picture so I can look at your, Aram, do you have that calculator with you? I don't see, I found your picture, but it's blank. Can you turn on your video camera? What I'm gonna do is have you show me your calculator, and I can tell you right away if it's gonna be a good one or it's gonna just make your life miserable. Are you able to turn on the video? I have to try. Oh, good. Okay, great. Can you put it down just a little bit? Okay, so the good news, Aram, is that's not the worst one for the course. There's another one I was not sure if you had. So you can use that one, Aram. It's totally fine. The only issue is I have no idea how it works. So if you get into trouble with it, you're just pretty much going to be on Google with the owner's manual. The one that I have right now, the TI-30XA, I know how to use it really well, so I could help you with it very quickly. Like over email, I can send you a calculation sequence, buttons you need to push. I just won't be able to do that with the Casio. Anybody else have questions? There are also a lot of internet websites out there too that have internet calculators. Some people really like to use those. And I know you guys are going to be using the internet during the test and everything like that. So if there's scientific calculators and you want to know what functions they have, you can get in touch with me about that, and I can try to help you find which one's going to be the best for the course, because there's certain things that you need to make sure that they have, and you don't want to be hunting around for in the middle of the test. All right, if nobody else has questions, you guys are welcome to take the rest of the day off. Go out and have some fun for a while. And we talked about the homework exercises. We'll see each other again on, Tuesday. We'll get into the frequency distribution stuff. And hope everybody had a good time today.
Thank you.
Thank you.
Thank you.
See
Have a good
ya.
day, Professor.
Have a
Thank
great
you.
weekend.
You
Toda.